Hello everyone, I am Siddharthan. In this video, let's understand how we can deploy a machine learning model as a Dockerized API. Deploying ML models as API is one of the widely used methods, and when you have a user interface as a web app or an Android application, when you have a model deployed as API, it would be easier for you to integrate your model with those user interfaces. So let's understand how we can Dockerize an API that we have already created in this video. So let's get started. In my channel, I've already posted videos on how you can take a trained model and deploy it as a local API with Fast API, which is a library in Python, right? So I'm going to work on the same code, just adding like the Docker file and the required things in order to build this Docker container. So this is the notebook that we use in order to train and save our model as a pickle file. So you can go through this once if you are not clear with any steps. I'll also give the link of this video so that you can refer it. So this is the first step, which is to get a trained model, which is this diabetes model.pkl. So once you run all the cells in this Jupyter notebook, you would get this diabetes model.pkl file, and this is the file that we will be using for our deployment. So I'll give you a GitHub repository link where you can find all these code files and the required files that you need in order to run this. So you can find that repository link in this video description. And the next step is, now we have a trained model, and now we are going to use this Fast API in order to deploy this as an API, right? So let me just close this. This is the code for it. Again, this is the same code that I've used before in the Fast API video. So you can find that video link in this video description. So I've just changed few things. So in that video, we have used a different way in order to get this input values. So the library has been updated. So I've changed this to just get this with input parameters dot pregnancies. In that video, we would just got these values just like getting some values from the dictionary. So this is the only change that we have. And yeah, and that is all. So I'll just give you a quick overview on how we could do this deployment with Fast API. So we are having this JSON library, pickle, Fast API, and pydantic. So in this pydantic we are using in order to process the input data that we get. So here we are creating this variable called as app, which is equal to this Fast API that we have imported, and we are creating a class called as model input, and we are using this base model from pydantic. So here you need to take all the input features that your model requires and mention what are all the data types of those input parameters. Let's say we are going to pass integer value for this pregnancies, integer value for glucose, and so on. So for BMI we are passing a float. So this is the first thing that we need to do. And the next step is loading the model, this diabetes underscore model.pkl. So we are reading this model and storing this in the variable called as diabetes model. So the user will pass in those values that are mentioned here, and then we will predict whether a person is having diabetes or not with this diabetes model. So here we are having this app.post. So whenever you're posting some data, we will be using a post API, and the other widely used API that you have is a get API, where you call that and you would get some output from it. So here we need to post these input parameters as a JSON and get the prediction. So that's why we have this @app.post. This app is nothing but the app variable that we have created here, app.post, and this is the endpoint that we are going to use, which is this diabetes prediction. So then we are creating a function called as diabetes pred, and here we are saying that the input parameters will be this model input. It's just like it would refer into this model input class in order to understand the data types and how you can unpack the values from this input parameters. So again, these input parameters will be given by the user. Then we are just like unpacking all these values, the pregnancies, glucose, and all those values, and creating a list as pregnancies, glucose, and so on. And then we are passing these values to our diabetes model and predicting the output, which is this prediction. So the output will be 0 or 1. When your prediction is 0, that means the person is not diabetic. When the prediction is 1, that means the person is diabetic, right? So we have this prediction of 0 is, so basically we get a prediction. If the prediction value, the first value of the prediction is 0, we say that return this dictionary, which is label is 0, and the result is the person is not diabetic. Else condition is nothing but the prediction would be 1. So in that case, we would send the dictionary as label of 1, and result as the person is diabetic. So just return the result. So this is pretty simple code. Now let's just run this on our local and test if this works. So for that, this is an app folder. Okay, so let me go to a previous directory. Okay, so this is my project directory. So I would prefer or I would suggest you to use PyCharm so that you can access the terminal easily, and if you want to debug, you can also like do it easily, right? So here we have this app folder where we have our trained model main.py file, which is our code for deploying the model, and then we have the requirements.txt. So here we have two requirements file. One is so this is my project directory where I have my virtual environment library stored here, and the app folder that has like all the code files required for it. This is the data set, so diabetes.csv, and then I also have my notebook file in this project folder, and this requirements.txt is the library list of libraries that I need in order to train this model and create this fast API, basically deploy your model as an API. So all those are here, and the requirements file that you see within this app folder is the requirement file that your Docker container needs. So that's the difference. So the one that you have is used to basically train your model and deploy it as fast API, and the one that's present within the app folder is for Docker container. So that's the difference. Now let's see how you can deploy this, or how you can run this API from your machine in the local. So if you see, I'm currently in the project directory. So I need to navigate to this app folder where my main.py file is located. So I'll just do a cd app folder. So now I'm in this app folder. So now I will say uvcon space main colon app. The main is nothing but the name of the Python script that we have, and app is the fast API application that we have created, the variable name that we have over here. If you're using different names, you probably have to change this, but these are the standard names that we use. So I'll say uvcon main colon app and just press enter. So you need to run this on the terminal, and here I can see the URL from which I can access this model. So I'll click this. So this will open this URL. So now this is saying detail not found. That's because you need to specify the endpoint, that is diabetes prediction. So for this you can just say /docs. This will open this Swagger page where you can test this model. So I'll just do this drop down and I can say try it out. Now I can just put in the values. Let's say the pregnancy value is 2 and glucose level is 100. Blood pressure value is 110. Skin thickness, let's say 10. I'm just putting some random values. You could refer to the dataset and use like proper values. And let's say insulin value is 100 and the BMI is 25 and the diabetes pedigree function is, let's say, 0.253 and the age of the person is 30. So now if you do this execute, this is the URL that we have called, and yeah, this is the result, which is labeled as 0 and it says the person is not diabetic. So you can download it. It's basically a JSON object, so you can see, right? So this is how you can test your API. Okay, so everything is working well. You can see the response is 200. That means like it didn't like create any issues, create any errors or something, right? So I'll stop this with Control C. So we have tested our API from the local. Next step is dockerizing this. So I hope you already know what is meant by a Docker, but if you don't, I'll just give you a quick overview of this. So Docker containers are like lightweight isolated applications that you can run that has all the dependencies that you need or that application need. If you think about this, right? So this main.py, the Python file that we have created, right? So it requires Python to run. It requires the libraries like fast API, Pydantic and so on. Now usually in software projects, so you would probably have a development team, testing team, and probably a deployment team and so on. Now when you work on something, so you have the code ready. The one way to kind of send this code to the other team is you could probably send those code files to the team, ask them to install Python and the required libraries and run it, or you can also containerize this so that all the required dependencies are kind of packaged and you're sending it, right? So that's the main advantage of Docker, where it doesn't create any conflicts with the versions that they use, let's say the Python versions or the other library versions that they use. So that's like one of the main advantages. So it's basically like containerizing or isolating your application or your script with the dependencies that it needs. So this is like one of the advantages of Docker. Now, in order to Dockerize this is a very simple process. All you need is a Docker file that says you the set of instruction that it needs in order to run this script. So that's what we will do next. So use this same kind of code structure. So you have this default working directory, so you can basically name this anything, and then you have this app folder where your required files are present. So you always, I mean, you need this trained model. We have this diabetes model.pkl stored here, and then we have this main.py and requirements.txt. so these are the important files that you need. In order to deploy this as Docker, you don't need this data set, and you don't need this notebook, because we have already trained the model and saved this. So within this app folder, I'm going to create a new file, which is a Docker file. So you can also give kind of like new and create this Docker file, but it should always have this name. So Docker file with only D being a uppercase letter. Okay, so now let's see how to add instructions to this. The first thing that I'm going to mention is the Python version that we need. So I worked on 3.10. So if you're working on 3.9 or 8, you can mention the corresponding version. So I'm going to say from, so let's put this on caps, from Python colon 3.10 hyphen slim. So this is one of the Python version that the Docker uses. So within this 3.10 also you have slim, bookworm, and other versions. I'm going to go with like the slim version. So this is sufficient for our application. So this, maybe I'll also put a comment saying this sets up the container with Python 3.10. And the next step is copying all the contents of this app folder to that Docker container directory. So I'm going to say, so, or maybe first I mention this comment as this copies everything in the Docker file directory. When I say Docker file, the directory of wherever this Docker file is present, Docker file directory to app directory in the container. So in the container, we will be having a folder called as app, and that's where we'll be copying all those files. So I'll say copy space dot space slash app. When I say dot, this means like the default directory, or not the default directory, the directory where the Docker file is present. Let's say you have another folder as, let's say, Docker, and within that, let's say, maybe I can create another folder saying that Docker directory, and within that, let's say the Docker file is present. So you would mention like that path here, so slash Docker directory, and then you say space app. So this is basically like wherever your Docker file is located. So for now, I'll just delete this. Okay, next is we need to change the working directory. So all this happened within the Docker container. So, or basically the Docker image. Let's maybe discuss the difference between those two later as well. So I'm going to say work dir working directory should be slash app. Okay. Now the next step is installing the required libraries, installing the dependencies, basically the Python libraries that we need. So say run pip install our requirements.txt. Okay, so next is we need to mention the port that our API is going to kind of run. So I'll say this as exposing port 80. So this will be the 80 that sorry, this is the port where a fast API will be running. So I'll say expose 80. And finally, we need to do this, mention the command that we have used, which is uvcon main app, right? So here it would be, let's say, command to run. So you should always put this in this CMD and mention a list and separate like all the words within this list with commas. So I'll say uvcon main colon app, and then host So this is in order to map the port that we have created. So I'm going to say 0.0.0 and let's say port. So these are like the default things. So if you're kind of deploying some other machine learning models here, right? So you don't have to change anything on the Docker file. So just like use or replace that particular train model here, or you may need to do some changes in the fast API script. But the Docker file and other things, we don't have to change anything. Okay, so that is all. So I'll save this UVCon main app host the URL port 80. So I'll save this. Now let's start building our Docker image. So I'm in the app folder. So make sure you are in the directory where your Docker file is situated, right? And also before that, right, make sure that you have installed Docker as well. So for Linux, you can just install Docker from the terminal. For Mac and Windows users, you can go to Docker site and install Docker desktop. So it is like a graphic user interface for Docker. So it's like really useful as well, but you can also work from terminal. That should be also okay. So first I'll say, make sure that you are in this app folder where your Docker file and the other scripts are present. So say Docker build T. So here we are going to tag it with the name. So I'll call this as diabetes red API colon, and you can mention a version number. Let's call this as v1.0. Yeah. So space dot, again, this is to mention that Docker file is present in this directory. If this is present in another subdirectory, you should probably like mention that here. So I'll press enter. Okay, so I made a typo here, so I'll run this. Okay, Docker, and you should run this with sudo with admin privileges. So if you're working on Linux, use sudo command. If you're working on Windows, make sure that you're kind of running your PyCharm as administrator. You can also kind of do this with your command prompt or Anaconda prompt. So open that as administrator. So now I need to put my password. So this will start building my Docker image. So basically it runs like all these steps one by one. So first is installing like the Python 3.10 Slim, copying the contents of this directory, changing the working directory, running the pip install r requirements txt, which is the current one running. You can see also the steps that we have. So basically we have like 4 steps so far, right? So pip install thing, and then we have this expose 80 and command to run, which is cmd uvcon main app, this thing. Okay, so this will build our Docker image. So you need to understand the difference between Docker file, Docker image as Docker container. You can also do some research about it. I'll just give you a simple analogy that you can understand. So Docker file, it's just like a recipe of a meal, or you can think about this as, let's say, steps 2 steps on how to manufacture a car. And a Docker image is basically like the infrastructure that lets you to build a car. All that you're interested in is building a car, and for that you have a plan in order to, or plan on how to build a car, right? That's how, I mean, that's what a Docker file is. And Docker image is just like an infrastructure. It's like a factory that, let's say, builds the car. So it needs all the infrastructure that required to build that car. So in this, let's say the infrastructure would be Python and the files that we have and all those things, right? And the steps that you need to follow. And the container is basically the car that we are building, right? So Docker file is the recipe or the plan. Docker image lets you have all those infrastructure, and with that infrastructure, you finally kind of create those containers. So the first step is creating Docker file. The next step is running this Docker build. When you say Docker build, it creates a Docker image, and finally you would kind of create a container. Okay, so I'll clear this. And for running the container, make sure that you are in the home directory of your PC. So this is my home directory. So you can do the CD with this. So it will take you to home directory. And now I can check the Docker images present in my system. Okay, so it says permission denied. So I need to run this with sudo Docker images. So this is the only Docker image that I have. So this is the size, which is diabetes spread API v1.0. You can also check the list of containers running with Docker ps. So again, I need to put sudo Docker ps. So you can see no container is running for now. So with this Docker image, we will create a container. So I'll clear this. and let's again run this sudo docker images. Now let's say docker sudo docker run. So you can copy and paste this repository name and the tag, or you can also copy this image ID. So I'll say docker run sudo docker run, and you also should say docker run -p 80:80. So this is the port that we have configured for our fast API to run here. So this exposing 80 thing. So this is how you need to run the sudo docker run -p. So this is for mentioning the port 80:80, and this is my image ID. You can again use repository name and the tag. So I'll run this. Right, so it says that this is where your UV is running, just like the same way we have tested this on this in our local. So I'll click this link. So this takes me here. Again, in order to test this, you can go to docs. So this link may not work in Windows sometimes. So in that case, instead of using this IP address or basically this URL, you need to use the localhost URL. Just go and type localhost and say /docs. So that will take you to this Swagger page. And here I can like test it and make sure that it works. Again, I'll just give this try it out, and I'll put some random values and see if I'm getting any predictions or there are any errors. Right, so I'll say blood pressure is 110, skin thickness is 8 or something, insulin is 95, BMI is 30, diabetes pedigree function is 0.253, and age is 30. So let's say execute. Okay, so now we have the label as 0 and the result is the person is not diabetic, so it's working. So now we have our API running, but not just as a Python script or a Python application, but just as a Dockerized container. Okay, so this is how you would do this. I'll open another terminal, and as I said, you can just go to my home directory and say docker ps. So I need to do sudo docker ps id 0987. Right, so this is my currently running Docker container. So if you want to stop it, you can come here and say Control C. So this will stop your Docker container. So this won't like work anymore. Okay, right, so it's not like running for now. Okay, so this is how you can stop your Docker container as well. So now let's see how we can delete this Docker container. So we have stopped it, but that Docker container is still in your system. So I'll say docker ps-a. So this will show you all the containers including running and the ones that are like not running. So I should say docker sudo docker ps-a. So this is the container that's present. So there is a command to delete all the containers that's present in your system, not just one. Or you can also delete this with sudo rm with this docker thing. But I'm going to delete all the containers present in my system. So I'm going to say sudo docker container prune. So this will prune or delete all the docker containers that we have. So it asks you for confirmation. Now you can again check this sudo docker ps-a. So this will show you. If you want to remove your docker image, you can say sudo docker rmi -f, which is force delete, and that particular image ID. So that would be sudo docker rmi if, and you copy and paste that image ID which is like present here. So this is your image ID. So if you copy and paste this and run this is like a forced delete, so that you can do that. So if you run this, your image will be deleted. So let's again create, or let's run a docker container from this. So this will create another container for you. So now what I'm going to do is call this API from this URL. So I'll create another Python file, not in this app folder, but in the default working directory. So I'll create a Python file and say, let's say testing YAML API. This is not an API, but a Dockerized API. So I'm going to say import JSON, import request. So we are going to use the request library in order to call this URL and get a prediction out of this. So both these libraries are like installed by default. You don't have to install this separately. So they are like a default installation of Python. So here we need to pass in the data or the input data, basically the model needs. So I'll maybe again go to this URL, go to this /docs. Here I can go and copy the template that I have over here. Okay, so now I'll paste that here. So I'll call this as data, input data. Okay. Now let's say we can't pass this dictionary and get a prediction from this URL. So we need to pass, pass this as a JSON object. So I'm going to say URL is equal to, and copy this from here. Okay. So copy and paste this URL here. Make sure to include your endpoint as well. Here your endpoint is nothing but the diabetes prediction. You can also see this in Swagger. So in Swagger you can see the URL for the same, yeah, diabetes prediction. Maybe you can just execute it with some, try it out, execute just with all the values as 0. I just want to look at the URL. So this is the request URL. So copy this and paste this in your testing URL. Now see JSON object is equal to json.dump. We are using this JSON library in order to convert this dictionary to a JSON object. json.dumps and say input data and response. So this is where we are going to post our JSON object and get a response. So response is equal to request dot post, and first parameter is your URL, the next thing is your JSON object. So say data is what we are passing. In the data parameter you need to pass the JSON object that we have created. Now so the output that you're going to get is a JSON again, right? So say print response. So when you print response, it will just show you as 200. That's the response code, right? Which is for successful response. I'm going to say response.json and let's run this. So now what happens is our container is running and our API is in this particular URL. So I'm mentioning that URL and using this endpoint, which is diabetes prediction. So basically it's like you can have multiple endpoints like this and call the other APIs as well. Let's say that you have art disease prediction API or endpoint. You can just copy the same contents and create another endpoint with a different function. You can use those two endpoints in a single API as well, just by changing those endpoints. So I'll run this. Found method response. Okay, it says response.json. Maybe I'll say response.text. Oh, okay, I should say response.content. I think it's for bytes, but we can test this out. Okay, so this is in bytes, but it says like label of 0, result is the person is not diabetic. I can also say response.json should also work. Yeah, but I think it says the response code. So we can also print this as text, response.text. Now you're getting this as label 0, result is the person is not diabetic. Okay, so this is how you are deploying, this is how you can containerize or dockerize your ML model as API, and you can get a prediction out of this. So when a person is let's say working on a user interface, like let's say a JavaScript tool or an Android application, once you have deployed it, you can just give them this particular URL and the expected data format, right? And they would just integrate that with their UI. Let's say in the user interface, the user would pass in those values and press some button. When that button is clicked, so this API will be called and this data will be posted and they will get a prediction. So maybe I'll try to change these values, right? 100, blood pressure is 120 and skin thickness is 10, insulin is 100, BMI is 25, diabetes pedigree values 0.325 something, age is 35. Right, so this is how you can test your API in Python. Okay, so yeah, that is all about deploying this Dockerized API. Maybe I'll just give you a quick recap of what we have done. So the first step is taking your diabetes dataset, training a model, and saving this as a pickle file and storing it in a folder called as train model. So we have this diabetes underscore model.pkl. Next, build this you know model as an API in your local. So for that you can use fast API, pydantic, and other required libraries. So here we are creating a post API with the endpoint diabetes prediction, and it gets all the data from the user. So these are all the input data type required, and then it passes these values as a list to our diabetes model, and then get a prediction out of this, and this would give you the result as label as 0, or the result the person is not diabetic, and then we have here 1 and the person is diabetic. So once we have tested this with the command uvcon main colon app, we can move on to dockerizing this, where we say that these are all the list of things that needs to happen while building the Docker image. So we build the Docker image with docker build -t with tagging and all those things. Then we build this build this container with Docker run, right? And the other thing that you could do is also push this to a Docker app, right? So in my previous video, I explained how you can deploy a Streamlit app as a Docker container. So there I've showed you how you could push this Docker image that you have built into a Docker app, right? It's just like GitHub, but let's say GitHub for Docker containers, not the Docker containers, but for Docker images, so that someone else can use your pre-built Docker image and they can like kind of use those APIs. So that's the old idea. Okay, so I hope everyone is clear with this, and I'll share this GitHub repository URL which has like all the files required, so you can kind of work on this same time you are watching this video. So use this probably the same code structure. So you have this app folder where you have this Docker file, train model, main py requirements.txt, and so on. Okay, so that's it from my side, and I'll see you in the next upload. Thanks for watching.